now we're going to look at each joint and just try and figure out what other forces I have. So, I'm going to start with joint A. Now, why am I starting with joint A? Well, first, it's just joint A. It's the first one that I think of. But it also has very few forces acting upon it, so maybe it'll be easier to find out stuff. I probably wouldn't use D just because there's a Y direction, there's an X and a Y direction, and an X and a Y direction. That's a lot of stuff that I don't know about. Same with B. There's an X and a Y, an X. So like I wouldn't know about that stuff. C might be a good place to start as well. E probably not, just because of all of those forces. But joint A, definitely. Let's look at that. The only X component forces is this and this. So I actually know the force within member AB, really, because here, this is the only X force, and it has to counteract RAX. So that means we have to have this force reacting positively, and it has to be the same. Force within AB has to be the same as the force for RAX, right? The reaction force in the X direction. So it has to be the same, and in the opposite direction. So what was that? RAX was 77.5. That means FAB will also be 77.5 pounds. And this will be in the positive direction to counteract that. Now, I don't have any Y forces acting on this, other than this one, right? If this had a magnitude that's not 0, then the joint would either be moving upwards or moving downwards, depending on which way this is pointing. But there's nothing else to counteract that. So this must have a force of 0 pounds, like 0 pounds. So FAD, that's going to be 0 pounds. Has to be 0, otherwise joint A would move. Remember, I'm thinking the sum of all the X forces have to equal 0. The sum of all the Y forces have to equal 0. If there's only one force, that force has to be 0. Otherwise, the joint or whatever would move. So here, there is no force. So I'm just going to disregard that, right? And I know now that this had to point opposite this. That means it's pulling on joints A and B, which means this is under tension. So AB is under tension. So there we have that. That's cool. See, now the first thing I would have thought is like, oh, this has to be going to this is going to the left, so that means this might have to be going to the right. But we're not exactly sure about that, just because we have another X component for that. So can't really do anything with that yet. So I'm just going to move on to joint C. So I'll move on to joint C, just because it has very few things. I already know that there's a Y component of this, and it's the only other Y component other than the load. So this Y component has to be equal to that load, but in the opposite direction. And then, well, this also has an X component, and this is the only other force in the X direction. So this force has to counteract the X component of that. So we'll start there. We'll start with that stuff. Joint C. So the first thing I'm thinking is, okay, I'm reacting down. That means the Y component of that has to go upwards, which means this force has to be pointing towards the joint. And so we can have this here. And then we also know that that means the X component of that force would be this way, so that has to be pointing to the left. So that's important. I already discussed that. I said that. There ain't nobody here. Alright. I know also, because the only Y direction forces are 35 and the Y component of, what is that? EC. I know that FEC in the X direction must equal 35 pounds. And remember, you can only use SOHCAHTOA or Pythagorean theorem if you're dealing with a vector and its components. So I already know that the X component of that is 35 pounds, and it's going to be positive. Sorry, not the x direction. I'm confusing myself. This is down. This should be y, right? I know that has to be 35 pounds, and it has to be positive. So I'm going to draw a triangle. I need to figure out some angles, I think. So if I'm drawing a triangle, this force would be EC, FEC, that's what I'm concerned with. And I know the y component, that's labeled poorly. Well, in order for me to use SOHCAHTOA, or Pythagorean theorem, or whatever, I need to know, well, I guess not Pythagorean theorem, but in order for me to use SOHCAHTOA, I need to know that angle right there. And that angle, right, is just based on this. That angle is going to be the same as that angle. And I know the dimensions for that and that, so I can figure out that angle. So that's what I'm going to do. This angle is the same as the angle that I want. So I do have that this was 10 and this was 30. So I'm going to use tangent, right? Let's call that angle theta 1. So we have that. That means tangent of theta 1, that'll equal the opposite, TOA, the opposite, 30 over 10, which is just 3. So tangent of theta 1 is just 3. And then I do arctangent, that will give me theta. And that gives me 71.565 something degrees. So I'll leave it like that. Okay, so if I know that, then I can figure out my FEC, my force, right? That's what I want. So FEC, what is that? That's the hypotenuse. So I could use cosine is adjacent over the hypotenuse. So I'm going to use cosine of the angle, which I just figured out, 71.565. 71.565. That has to equal 35 over FEC. And then I'll switch those two. So EC equals 35 divided by the cosine of 71.565, and I'll have FEC. And that gives me 110.679 pounds of force, and we already know the direction, don't we? So that's joint C. Maybe I'll box that in. Whew! FEC. Well, oh, do I not have enough? No, I do. We're good. So that means this one's pointing in that direction, right? So this is compression. That's under compression. FEC, done. EC is 110.679 pounds under compression, I think, right? Compression. So that's very good. And now, since I have FEC, I can figure out the x component, right? Remember, this had to counteract the x component of that. So if I just find the x component, I have found that. Because those are the only two forces in the x direction, so they have to be equal and opposite. I can actually just use SOHCAHTOA again. If I have the y component, I can get the x component by doing tangent, right? Tangent of the angle, tangent of theta 1, which is 71.565. That would equal TOA, opposite over adjacent. So the x component, which is, well, let's see, multiply both sides by 35, so then FEC in the x direction has to be 105 pounds of force. And I know that FEC in the x direction, that has to equal, where is it? So FECX is there. Well, BC, that has to be the same. It's just in the other direction. So FECX, that equals FBC. So FBC equals 105 pounds. And we already decided, well, since that arrow was pointing that way, this arrow has to point this way. It's pulling on these joints, so it's under tension. So we have BC. Sweet, just moving right along. Where's BC? 105 pounds, and it was under compression, I think. No, tension. Undo. Tension. There we go. What else do we think? It's time to move on to the next video. Okay, moving on.